This is 8.2 ellipses. With an ellipse, you have two options. You have a horizontal ellipse or a vertical ellipse. We are going to cover ellipses that have a center at 0, 0, and I will run through the formula and all the different parts of a horizontal ellipse, and then I'll go through the same details for a vertical ellipse. So first of all, on the left-hand side here, I'll draw a line just to kind of separate these. With a horizontal ellipse, you've got x squared over a squared plus y squared over b squared equals 1. And a squared is always larger than b squared. So the a squared is always larger. No matter what. If it's under the x squared, we have a horizontal ellipse. If your a squared is over here under the y squared, you have a vertical ellipse. So with a horizontal ellipse, because you have it's horizontal, your vertices are also on the horizontal axis of the ellipse, and the value of a would determine that. So you take and add and subtract that from 0. If you start from your center of 0, 0, and you add a, you would have positive a. If you subtract a, you'll have negative a. So when you know your value of a, you are adding and subtracting from your x value of the vertex. Your co-vertices are made up from the b value, and they are adding and subtracting from the y value of the vertex. So you're going to have 0, because the 0 on the vertex does not change, and then positive and negative b, because you're adding and subtracting b from 0. The major axis is from one vertice to the other vertice, so it's the long length of the ellipse, and so that's running horizontal because the ellipse is horizontal. And the length is twice the value of a. The minor axis is the short length of the ellipse, so that is vertical, and the length is 2 times b. Now the foci of the ellipse are found by taking a squared minus the b squared, and that's going to equal c squared. So if you take the square root of that, so you think about the fact that c is equal to the square root of whatever you get from subtracting a squared minus b squared, and that's what you'll get. And again, it's stemming from the center at 0, 0, so you're adding c and subtracting c, so you get positive and negative c, comma 0. So whenever you see that positive, negative like that, it's basically you're going to have c, comma 0 for one ordered pair, and negative c, comma 0 for the other ordered pair. Okay, so when we look at this graph, this is a horizontal ellipse, and let me get a fine point pen here. Sorry. This right here, these are your b values, the co-vertices. So this is going to be 0, b, and down here is 0, negative b. On the long end points, those are your vertices. So on the left here, that is negative a, comma 0. Over here on the right, you have positive a, comma 0. And these points on the inside, these are your foci. And the interesting thing about foci is if you take a line from the foci to a point on the ellipse and go to the other foci, no matter where you do that, you go over here and then over there. If I add those two lengths together, where you're going bouncing off the ellipse and over to the other foci, add those two lengths, it's going to be equal to the other two lengths that you did. So no matter where you are on the ellipse, you could do that, and those lengths will be equal to each other. Other than that, the foci are giving us the value of c. So this foci is negative c, comma 0, And this focus point over here is positive c comma 0. So that's the basic understanding. So the major axis is this full length. So that's why it's 2a, because you're going a units to the left and a units to the right. Your minor axis is up and down, so you're going b units up and b units down, so it's 2b. So that's how we understand everything about the ellipse. Now, understanding these points and what they do with the graph helps you understand how to get them as points. All right, so for the vertical, as I explained before, the a squared is going to be under the y squared. And remember, the a squared is always the largest value between a and b. So the vertices would be 0, and a goes up and down. So positive and negative a for your y value. Co-vertices, the shorter length, is going to be sideways when you're talking about a vertical ellipse. So you're going to have positive, negative b comma 0. Your major axis is going to go just like the ellipse vertical. So you have vertical, and that length is your 2a. Your minor axis is opposite, so horizontal, and that length is 2b. And for the foci, again, you're going to calculate the same way we did over here, but you're adding and subtracting from the y value of the vertex, so you're going to end up with the origin at 0, 0. You have 0, comma, positive, negative c. And looking at the graph, our major axis is going up and down, and so we have 0a for that ordered pair, 0 and negative a, that's a 0 for the ordered pair down there, and then sideways horizontally is our minor axis, and we have b comma 0 and negative b comma 0. Our foci are going to be on the 0 comma c, and on the vertical axis, and 0 comma negative c. Okay, and obviously our center is in the middle, and for both of these, our center is the origin. There's also a thing called eccentricity. The eccentricity is found by taking the value of c and dividing by the value of a. You just leave it as a fraction most of the time. And what that tells us is if c over a is very close to the value of 1, then we have our ellipse is close to being a circle. Circle. So the further away from being the value of 1, the more flattened your ellipse. So these ellipses right here, you're not going to have a eccentricity that's close to 1 for these ones that I have up in the example. All right, let's look at some examples here. Here I've got x squared plus y squared over 9 equals 1. I need to find the vertices, co-vertices, foci, eccentricity, and then determine the lengths of the major and minor axes, and then graph this. So let's do this in red. Let's get the fine point. All right. What I need to realize is if all I have is x squared, I need to put this over 1 because I need to have an a and a b value. So right now, a squared is 9, b squared is 1, and that tells me this is a vertical parabola, ellipse, not a parabola, and a equals 3 and b equals 1 because you're taking the square root of both of those numbers. The other thing I need to know is where's my center? Since there's nothing added or subtracted from x or y, my center is at 0, 0. And so my vertices, since I have a vertical parabola, my vertices are going up and down. So I am changing my y value with the a. So that is going to be 0 and positive and negative 3. Remember, that is 2 different points. That is 0, 3 and 0, negative 3. And for the co-vertices, those are going to go sideways, so you're affecting the x value, and so that's going to be the b value of 1. So positive and negative 1, comma 0 are the co-vertices. The major axis is going to be twice the length of A, so 2 times 3 is 6. The minor axis is twice the value of B, so 2 times 1 equals 2. The foci, I need to do some work here. I have to take c squared equals a squared minus b squared. A squared is 9, b squared is 1, so that is 8. So c squared equals 8, which means c equals the square root of 8, which is 2 times the square root of 2. So for my foci, again, they're going to be along with the longer length of the ellipse. So that's vertical. So that's going to add and subtract from the y value of the vertex. And I get positive and negative 2 times the square root of 2 for my foci. And for my eccentricity, I'm going to take the value of c, 2 times the square root of 2, over the value of a, which is 3. And so this is all my information. And now I am ready to graph. So to graph this, we are going to start by plotting the center at 0, 0. And then we're going to plot the vertices at 0, 3, and 0, negative 3. And I'm going to fix this because you can see that this is not very close here. Hold on. And all right, so we have the co-vertices at 1, 0, and negative 1, 0. And the major axis is just the length from top to bottom. The minor is just the length from side to side. As you can see, it's 6 and 2. And the foci, 2 times the square root of 2 is around 2.8, 2.9. So that's just going to be in here. So we're really close up to the vertices up here and down here. Those aren't going to be part of the ellipse, but they're, as I told you before, those gives you information about the ellipse. So now I'm going to grab my ellipse tool and see how well this looks. And my ellipse is going to look something like that. Okay, and there we go. So the main thing is getting all this, and then just being able to plot the co-vertices and vertices to draw your ellipse. And then example number 2. Now when we look at this, it looks a little strange. We usually are used to looking at something where it says x squared divided by a number and y squared divided by a number. Oops. And it's supposed to be equal to 100, or 1, not 100. So what we need to do is we need to divide everything by 100 and simplify these fractions. So I end up with 1/4 here, which means x squared over 4. 25, wait, 4 over 100 is 1/25. So we're going to get x squared over 25. 25 over 100 is 1/4. And you're going to get 1, so we get y squared over 4. And 100 over 100 is 1. So I have my a value, which is the 25. A squared equals 25. So a equals 5. Y squared, or b squared, is 4. So b equals 2. And there's nothing added to the x or y, so my center is 0, 0. My vertices, add the 5. So positive and negative 5. add and subtract the 5 from the x value. So I get positive 5, 0, negative 5, 0. My co-vertices are going to be added and subtracted from the y value. So I get 0 and then positive and negative 2. My major axis is twice the value of a, so 10. My minor is twice the value of b, so 2 times 2 is 4. My foci, I take 24 minus 4, which is 21. That's my c squared. So c is equal to the square root of 21. And that is going to go left and right, just like the vertices. So I get positive and negative square root of 21, comma 0. And my eccentricity is the value of c over a, so the square root of 21 over 5. So now I go to graph this. So 0, 0. 5, 0. And let me fix this. All right, so my vertices are 5, 0, 5, 0, and negative 5, 0. My co-vertices are 0, 2, and 0, negative 2. And that's all I need to be able to graph. So let me get, here's my ellipse. And it's horizontal, as it should be. Okay, let's look at these examples. We need to find an equation of the ellipse whose graph is shown. So what we need to be able to write an equation is we need A and B, and we need H and K. That's what we need to be able to write an equation. Our origin, our center, is at the origin, so that's 0, 0. So H and K, we're not adding anything to the X and Y. Our A value is the longer length on from the center on the longest axis. So from here, 0 to 4 is 4 units. So A equals 4. From 0 to 3 is 3 units. So B equals 3. And this is a vertical ellipse, which means A is going to go under the Y. So we have x squared. I'm not adding or subtracting anything because our center is at 0, 0. Over b squared, so 3 squared is 9, plus y squared over the a squared, so 4 squared is 16, and that's equal to 1. And that's our equation. Over here, we aren't given b, but we are given a. A equals 4, and the foci is giving us the c value. So going from 0 to the focus point, that is your c value. So that means the c value is 3. So we got to do a little bit of math here. C squared is equal to a squared minus b squared. So that means 3 squared, 9, is equal to 4 squared, 16, minus b squared. We subtract the 16, and we get negative 7 equals b squared, negative b squared. So you divide by negative 1, and 7 is equal to b squared. Now, if we really want to, we could break that down and get our b and get the square root of 7. But when we write our equation, we actually need b squared. So this is what we need here. So b squared equals 7. A squared is 16. And because this is a vertical parabola, my a value, a squared, goes under the y squared again. So I'm going to have x squared over 7 plus y squared over 16 is equal to 1. And there's my equation. In this third example here, we have our b value. As you can see, it's long, it's horizontal. So our b value is 2. And they're giving a point on the ellipse, which has nothing to do with a, b, or h and k. So what we need to do is use that as a point where we have an x and a y value. Since this is a horizontal ellipse, the a squared goes under the x squared. And y squared over 2 squared, which is 4, equals 1. I forgot to replace my x and my y. So my x I'm going to replace with 2. So I have 2 squared. My y is going to be replaced with a 1. So I have 1 squared. That gives us 4 over a squared plus 1 over 4 equals 1. So now I'm going to solve, and I'm going to solve this for a squared. So I'm going to subtract the 1/4. That gives me 4 over a squared equals 3/4. And here I can do my work to solve for a proportion. And I get 16 divided by 3. So a squared is 16 divided by 3. Again, that's actually what we need, so we don't need to worry about taking the square root of that. B squared, because b is 2, b squared is 4. And this is a horizontal ellipse, so the a squared goes under the x. So I'm going to write this up here. Actually, I'll move this down. Okay, so I get x squared over 16 thirds plus b squared over 4 equals 1. And now, since we're dividing by a fraction, let's multiply this by the reciprocal. So if I multiply, if I'm going to cross that out, and I'm going to multiply by the reciprocal, 3/16, which means I have 3 times x squared over 16. So 3x squared over 16 plus b squared, no, y squared over 4 equals 1. That's a y. And this is my equation. Okay, here we find an equation for the ellipse that satisfies the given condition. We have a foci at 0, 3, and -3. So our c value, if we realize that is opposite values, the center is going to be then 0, 0 for our center, for our hk. We have a c value of 3, and our vertices, same thing. We're moving 5 units right, 5 units left. So a equals 5. So we have to find our b. So c squared, 9, equals a squared, 25, minus b squared. I solve this. I subtract 25. That is -16 equals negative b squared, which means 16 is equal to b squared. And a squared is going to be 25. Because the vertices are on the y-axis, This is a vertical ellipse, which means I'm going to have x squared over b squared, so it's x squared over 16, plus y squared over 25 equals 1. And that's our equation. And then over here, the endpoints of the minor axis are 0, 3, so that's b. So b equals 3. The distance between the foci is 8. So that's saying going from uh, or one foci to the other foci is 8 units, and the center's got to be in the middle. So if the full length is 8, then half the length is 4. So our c value is 4. So then we're going to use c squared equals a squared minus b squared. And c squared, 4 squared is 16. A squared minus b squared, so 3 squared is 9. So here we add the 9. We get 25 equals a squared. And b squared is 9. And now we can write our equation. The minor axis went up and down. That means the major axis goes sideways, so this is horizontal. So we want our a squared under the x squared. So x squared over 25 plus y squared over the 9 equals 1. And that's it.